Hello guys, in this video, we are going to discuss how we can build a machine learning system that can predict the amount of calories burnt during exercise. So this is a very interesting machine learning use case because uh, uh, we face this in our day-to-day life regularly. A lot of people are very interested in exercise that do uh, 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 that they do and the diet that they take and what is the amount of calories associated with them. Say for example, how much calories they intake when they eat and how much calories do they burn when they do exercise. We will be using machine learning to solve this problem. Let's first understand what uh, what happens inside our body when we do exercise. So what are the metabolic activities that are taking place when we do exercise? So it helps as us to understand this problem statement better. So then I will explain you the workflow which we will be following for this particular project. So what happens when you exercise? So let's consider a person is exercising. He can do a heavy lifting like bench press, or he can just be running in a treadmill. So before 4 or 5 hours of his workout, he has taken some good meal, and energy in this food will be used by that person to do that exercise. Let's say that the person eats something that is more of carbohydrates, so these carbs will be broken into more simpler form like glucose. And when the person do some exercise, this glucose will be broken down and it will be converted into energy using oxygen. So the muscles that are doing exercise need more oxygen, and this oxygen is supplied by blood. As the body require more oxygen, now the heartbeat will increase a lot. Increased heartbeat means increased blood flow. So this increased blood flow will give more oxygen to the muscles. This oxygen will be used to break those glucose molecule. This is what happens. So when we do exercise, the normal heartbeat will be more. Under normal condition, average heartbeat is around 75 beats per minute. But when we are doing exercise, the heartbeat can be around, let's say, more than 100 beats per minute. So this is the one of the important influence. So only a part of energy is used while exercising. The remaining part is converted into heat. So the body temperature increases. In order to reduce this temperature, our body will release sweat. So this is the reason that we get sweat when we do exercise to cool down this body temperature. So these are important parameters we need. So we will be taking the parameter such as duration for which the person is doing exercise, and what is his average heartbeat per minute, and what is his body temperature, and also the height and the weight of the person will be the height and weight of the person will be used to predict how much calorie is burned. So let's understand the workflow. First step will be to collect the data. Once we have the data, we cannot feed it directly to our machine learning model. Before feeding, we need to process the data. So this step is called data pre-processing, where we can clean the data and do some processing on it. So this step is called as data pre-processing. And after pre-processing, we need to do some data analysis. This data analysis helps us to understand our data set better. It helps us to make better influence and better prediction. So third step will be data analysis, where we will use some visualization technique where we try to plot the data in some plots and graph. So once we analyze the data, the next step is to split the data set into training data and the test data. So the reason for this is we will train our machine learning model with the training data, and we will evaluate our model with the test data. After splitting, we need to train our machine learning model. So in this case, we use XGBoost Regressor and train it with the training data. Once we train the model, we will evaluate the model with the help of test data. So now let's move on to the coding part. So we will be using Google Colab for our project. So before the start, we will load the two data sets. Here we have two data sets. One is calories and one is exercise data set. So this is unique about this project as we have two different data sets. Let's start. So first we will import the dependencies. So in dependencies are nothing but the libraries or functions which we will be using in our project. So let's start. Import numpy as np, import pandas as pd, import matplotlib dot pyplot as plt, import cbond as sns from sklearn dot model selection, import train test split. So from XGBoost, we will import SCP regressor. So finally, we will import our matrix from sklearn, import matrix So this NumPy is useful to make arrays, that is list of values, and this pandas will be useful to make data frames or structured tables. And like this matplotlib and cbond is used to create plots or graph. And let's proceed with the data collection and processing part. So we will be loading the data from CSV file to pandas data frame. So remember guys, we have two data sets. So first I will take calories data set, calories equal to pd.read CSV. So click on this, copy the path. So I have loaded the calories data set into pandas data frame. Let's check the what is stored in it. So head. So like we can see only two columns. We need to distinguish between exercise, that is when person is walking, running or doing heavy lifting. So going for a walk, calories burnt will be less. When the person is running, calories burnt will be more. And when doing heavy lifting, calories burnt will be more. It will be even more than the jogging. So these are the calories content. So now I will take that exercise data. So exercise data pd dot read CSV. So let's check the exercise data head. So dot head. So you can see that there are gender, age, height, weight, duration, heart rate and body temperature. This user ID is similar to means like you can say these are the relationship between these two individual data sets. So now we have to combine this two data frame into one. So let's do that. So calories data equal to pd dot concat exercise data then calories I will take the calories column x is equal to 1. So there is an indirect relation between the heart rate and body temperature with exercise that they do. So let's check this calories data head. Like so the calories column is being added to this calories data set and both the two data frame is merged. So here we can see this as the temperature increases, it's like calories burned is more, but kind of here you can see the calorie is burnt is less. So now let's check for the number of rows and column in calories data. So that we will do. So we have 1500 data sets and 9 columns. So let's get some more information about the data. .info. So you can see these columns like float and some gender column is a categorical column. So it's object. So let's check for is there any missing values in our data sets or not. So calories dot is null. Dot sum. So we can see that our data set is clean as since we don't have any missing values in our data set. So moving forward, we will get some statistical measures on the data. So calories data dot describe. So you can see that account, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and the maximum of each column. So now let's proceed with the data visualization part. So this SNS.set will give some basic theme for our plot. So moving forward, all the plots we make will be having some basic theme while plotting. So that's why I have included it. So now let's start plotting the gender column in count plot. SNS.count plot calories data. We have gender. So it's a categorical column. So you can see the distribution. So male, it's like on male and female both are like evenly distributed almost. So let's start finding the distribution of age column. So for that we will use this plot, as it is a numerical column, so we will use this plot. We'll take the calories data. Inside that, we'll take the age. Yeah. So as it is a numerical column, so I have taken this plot. So you can see that more values are in the range of 20 and 30. The value is kind of decreasing. Then less people come to gym at older age. We know that, and we don't have much value less than 20. So now we will proceed to, like, we will start finding the distribution of our next height column. So I will follow the same process. Height column is a numerical column, so I will use dist plot. So it's kind of normally distributed. So more number of people are present in around 160 to 180 range. So it's the distribution is kind of normal distribution. So which is quite good for our model building purposes. So now our next step will be finding the distribution of a weight column. So let's do that. So weight column is also a numerical column. So we will use the dist plot again. So in this, like more number of people are in the range of 60 and 80. Some are people are in the range of 80 to 100. So we will proceed. So now we will find a correlation in the data sets. So as we know that there are two kinds of correlation, like positive correlation and negative correlation. Like in positive correlation, if one value increases, then automatically the other value also increases. And in negative correlation, if one value increases, the other value decreases. So let's start finding the correlation. So we will take our calories data and find the core. So the best way to find means plot the to see and visualize the correlation is the heat map. So we will now construct a heat map to understand the correlation. So plt.figure. Fixed size. Let's say 10,10. So SNS dot heat map, correlation, C bar equal to true, square equal to true, FMT is equal to 0.1 F. Annotation we will find it as true, and note KWS, and I will give size as, let's say, 8. C map, let's say blues. So I will run it. So this is our C bar is equal to 2. This like this this bar is called a C bar, and the squares it's in the square format. So 0.1 F FMT equal to 0.1 F is like a all values are in 1 decimal point. So these are the annotations which is true. So size of this is given as 8. So now if value is 1, like you can see two values are positively correlated. If value is very less, value is very less. So value is negatively correlated. If value is 0, then there is no correlation. So like if value is 1, then two values are more strongly positively correlated. If value is less, is very less value, so it's negatively correlated. And if it is 0, so absolutely no correlation is there. So we can see that if a person height, like if a person is tall, that person weight will also be more. So here also we can see that duration duration is like directly proportional to calorie, as it is in darker format, like so it is more positively correlated. So now we will convert the text data to numerical data. So like we have like gender column, which is a textual column, so or categorical column. So we have to convert it into a numerical column. So calories data dot replace so gender. So let's take male, and the female, keep it as 1. So we will save that permanently. So in place equal to true. So now let's check the top 5 rows of calories data set and see our imputation is done correctly or not. Calories data dot head. So you can see the gender column is replaced with numerical, since it was previously categorical column, and now it's a numerical column. So now we will start separating the feature and the target. So here the user ID is not required. So I will drop this column. And again, I will drop my target column. So in Y, I will put the target column. That is the calories. So now let's print the value of X and Y. So this is the value of X, and we'll print the value of Y. So these are the value of Y. So now we will split the data into training and test data. So X train, X test, Y train, Y test, train, test split, X, Y will give our test size is equal to 0.2, like, and we'll give our random state as 2. So basically we are splitting our data set into training and test data set, and the test size is 0.2, like 80% of the test 80% of the data set will be used for the training purposes, and 20% of the data set will be used for the testing purposes. And random state is equal to 2 means it is just to reproduce the same code. So like mine and your code will split in the similar manner, and our output will be the same. But then let's check the how data set is divided, like, so X train dot shape, X test dot shape. So you can see that we had originally 15,000 data set, and out of which 12,000, like the 80% is divided for use for training purposes, and the rest 3,000, that is our 20%, will be used for the testing purposes. So now we will do our model training, and here we are using XGBoost Regressor model. So let's start with loading the model. So model equal to XGB Regressor. So now we will train the model with the xtrain. Model.fit xtrain y train. So we have trained our model. So now let's move on to the evaluation part. So we will predict this model on the test data. So let's do that. So test data prediction, test. So we have to implement that model, our trained model on the test data. So model dot predict our, will pass the x test value. So now we will print this test data prediction. So like our test data prediction is shown here. So moving on, we will find the mean absolute error. And mean absolute error tells us what is the magnitude of the error that our model is making. So let's check the mean absolute error. So MAE matrix dot mean absolute error. We'll take the y test value and our test data prediction. So this is the mean error, mean absolute error. So we will print this. This one of our evaluation metrics only. So mean absolute error equal to MAE. So let's see what is our mean absolute error. So it's coming around 2.71. So this is a very good score. So like error value is very less, because it means like if the original value is 131, the model is predicting 129, and this is very close. So so there is no general value of mean absolute error here. It depends on magnitude of each value. So that's it. Like, and this is how we will take this calorie data set, calorie and exercise data set, you can say, and predict how much calories is burned. So that's it from my side. Hope you have enjoyed this video. Thank you.